Good afternoon, everybody. Welcome back to Scrap Mechanic Survival Unleashed. Today we are finishing up our factory floor and automated distribution network for the drone. First, I want to, mention that I was actually asked in a comment from last video, why am I not using this super simple system over here? And I didn't really have an answer for them. I guess the only answer was because I thought it would look cool if I had a little spinny thing, because someone suggested I make a spinny thing, and so I decided to make one, and it looks cool. But when I think about it, this is just so much simpler. So I guess I don't know. I could remove it. I might remove it. It's just I feel kind of like clickbaity from the episode where I said I was making this for the distribution network or for the factory floor, because I made this. And then if I remove it and delete it, then I feel like that entire video is pointless and I'll probably have to delete it. But, let me know what you guys think. I'll leave this here for now and I'll hopefully get some feedback on what I should do, because it'll be a lot simpler and probably a lot more precise if I just switch to that single wedge block method, because it won't like fall off on accident or slide off the wrong way, to be honest. So we'll see. Let me know what you guys think and I'll get that started. If you're new to this channel, first of all, welcome. Second of all, you may have already figured out by now, but I have a tendency to over-engineer things, and it's kind of a problem. I guess I wanted to say that I am re-engineering this logic part right here, because I realize it's pretty unnecessary with the way I have this set up. So I simplified it. I have this same system over here. All it does is just whenever a car passes over, it turns on this logic gate, and then that will make this turn on and turn to the right. It's pretty simple for this side. This side, it's a little bit less simple, but it's not as complex as I made it last episode. All right, so the logic fix as it goes is I added a sensor right here, a wheel sensor or drone sensor is what I'm going to call it. And essentially I need this to stay on at all times. That way it'll turn at all times. If I switch over to that other method, it'll be a lot simpler. It'll just be a piston that goes down and up, and that'll be it. But for now, we're going to have it so that it just stays on at all times. So that way, every time it comes over, it turns. And then any time that it harvests here, it just turns it off. So it's if either this one or this one gets triggered, it basically turns it off and makes it keep going straight. Like, it's really as simple as that. I didn't need any fancy like NAND gates or anything like that like I had last time. So we're just going to put that logic in and then be done with the gathering system over here. Okay, now that I've got the collection network set up, all I need to do is actually get to what I was going to do this episode and go to the distribution. Okay, this is going to be interesting because the way I had it before, I had these little bits right here, but I'm actually going to delete all of this. I really am not going to use that. I am actually going to move all sorts of buttons and stuff over to this control room. I know I have like logic over there, but I kind of want to keep the other sort of logic that involves all of this distribution network over in this control room connected through wire and concrete, because I can't trust wire. If we just go over here and figure out exactly where we want to lay out our farm, I think I'm going to have to delete all this, unfortunately. All right, we now have a blank slate. I'm going to have the either inputs over here, the drone location over here, and then outputs on this side right here on the third side. So we're going to have a little bit more space to work with. We can have some sort of semblance of a map, but I definitely do not want to do all that connecting up again like I did that one episode. So we're going to start with the output, actually. We're going to do it a little bit reverse. We're going to have the output as in what carrots or what vegetables do we have on our drone right at the moment. So we're going to have this will be kind of the distribution side. So when it gets over here, we can have little indicators. But right now on the inside, we're going to have just exactly, well, we can have it this way, yeah. So we're going to have little indicators. They're going to be colored, the colors of the crops. So I think it was like orange, red, beetroots, and broccoli. These will represent exactly what the drone is currently holding. With these, the factory will know and hold exactly what needs to be triggered for when the drone gets closer and actually at the distribution center. When I originally had this idea, I wanted to at least figure out some way to be able to count how many vegetables I had in each chest. so I could have like an exact dynamic time on how long I need the drone to wait at each station. However, that's not something I can do practically in vanilla, and I know I could easily do it in the mod pack or with the font mod, but I am only doing vanilla for this series. I know I mentioned I was going to do modded, but I decided a lot more people probably would be interested in something that they can actually do in vanilla versus having to download a mod and deal with all that, you know, file moving and all that stuff. But don't worry, I will be doing modded at some point, and I will be going back to regular survival too. Actually, if you guys are interested in that, I will be doing the grind for regular survival, only there will be a twist. So if you're excited for any of those series, please let me know, or subscribe. I appreciate that, actually, if you would do that, please. All right, these 4 spots will represent the actual sucking in parts, whatever, I don't know what to call it, the gathering resource packaging station sections. As you can see, they're in order with carrots, broccoli, beetroot, and tomatoes. I believe that's the order, I think, maybe. What we're gonna have here is little indicators to show where the drone is at as well. And we will color those black. And I'm going to have little, maybe not, maybe I won't do that. And then I will have a output, what is this called? So the drone will come in through one of these sides, and then the drone will exit down here. This looks oddly phallic, but it's a factory. It's a map of the actual thing. That's how it looks. Okay, so let's just color these black so that we can. Oh my gosh! Oh my lord! Okay, so what am I, 3? Okay. Anyways, so once the drone gets to this part of the factory, these lights will turn on, or this light will turn on, and then once I know it's being distributed, I will have also these lights turn on. And actually what I'm going to have are timers right here. So these timers will represent how long the drone is going to be staying at each location. So this will hold the drone at a specific location. The question is, how am I going to do that sort of logic? So what I'm going to do here is a timeout. Each of these are connected to bits. So basically, once the drone picks up that specific vegetables, it will turn on this bit, or whatever bit it is. And this bit will then go to this timer right here. And this timer will then go to this output right there. Oh, I messed that up, actually. I was thinking of a timeout, but I can probably do a time on. So what I mean by that is I have this output connect to, actually this is carrot, so we're going to have to connect carrot to carrot. I probably put these in the wrong order. I can just repaint them. You know what? I'm just going to repaint them. Okay, now they're repainted in their proper location. So if this carrot, we're going to go back to our previous example. If this carrot was on, it is going to turn on this, which is going to turn on the distribution center piston stopper thing that I'm going to have. And then that will stay on. However, once the drone actually reaches that location, it will then trigger this timer right here. And if this is on and this drone is on, it'll start a 15-second timer. And once that happens, all it will do will just turn off this bit. So that way it'll know that it's out of carrots, and it'll turn off this bit, which will turn off this, which will then retract the pistons and then make the drone move forward. It's really as simple as that. I talk about how this is as simple as that, except knowing the way how everything has been working so far, it's probably not going to work. But it's okay. We can figure out what goes wrong, test it, and then try again. Real quickly, I want to mention that I got a comment saying I should change the drone to look something like this, I believe is what they were saying. Maybe. I could be wrong, but basically it'll reduce this massive overhead sight and all these ugly pipes and reduce the weight. And I acknowledge that comment. It looks pretty good, and I do think it'll work. And if my current drone doesn't work, I might switch to it. However, the one problem I have is the weight distribution. As in, it's now going to be back heavy or front heavy, whichever side I decide to put these vacuums pump on, because these vacuums are very heavy. And that is what causes the weight to be weird. And if I have it on the wrong, not in the middle like I do on this side, then it'll be like wheeling or something else, depending on what happens. So we can try and see if it works at some point, but I just want to thank you for your comment and acknowledge it. I think I may have replied or liked it at least. But anyways, yeah, so if you have any more suggestions like that, please let me know, and then I can try them out in the future, and I will definitely acknowledge them at some point. One mildly infuriating thing about this setup is the fact that it's non-even, because there's a 2-block gap between these two right here, like that. So I can't have a central line, so I have to offset it by 1 if I want to have it. And it looks bad, but it'll get the job done, but it just looks bad, and I feel bad, man. Yes, first of all, before you say it, I am aware that I do not need this central panel thing at all. I can just shortcut it to just have those 4 logic bits. However, I am doing that just for visibility / visualization reasons, because it's fun, I think, more than just practical and efficient. I don't know. I just have fun having things look visual and making things make sense, even when they shouldn't. That's just how I like to make things. I know the logic isn't completely done for this part yet, but I wanted to get this set up just so that we can prove that it works. And this right here will be the basic switch that turns this left or right depending on which direction the drone is coming from. So right now it's facing this way. So let's say the drone is coming in on this side, and I can place this anywhere on this path right here because it'll never come from anywhere else. But let's just put it here just because. I don't know, just because I can. So let's pretend this drone is coming down this way. This controller is the controller that controls this control, you know, as many controllers can be controlling as controllers control. Okay, well, basically that controller that I had, I don't know what other. That controller twisted this wedge piece left and right depending on which direction or which power input it had. I am going to move that controller, said interactive component piece, over to the control room. And let's see, let's just put it over here just because, and then we're going to put a light, and we're going to keep it orange. Let's call it like blue or something. I don't know, call it a blue light, and then we can even color that wedge piece blue. But let's just put it here. Okay, now I have to connect this controller back all the way over to the bearing. If it's off, it'll be this side, and if it's on, it'll be this side. Okay, that's what we shall do. So basically, once the thing turns on, we're going to make it twist left 180 degrees, and that will be all. I don't think it matters how fast, but we'll do that just for good measure, just so that we can have it in place in time. The final touches will be to put these correct. The final touches will be to connect these sensors to the correct spots. And like I said before, this side will turn off the logic bit, making it twist over to the, I guess, right side, depending on which direction you're looking at it from. And this sensor right here will turn on the controller, making it turn over to the left side. Honestly, that's pretty simple. And if I switched over this to that same system, I kind of wouldn't complain because it'll make a lot less complexity over in the main areas. But as you can see, the bit has twisted, and I didn't even see it because I wasn't even paying attention. Let's try it again on this side and assume that it'll work. Okay, as you can see, it's facing the wrong way. If we turn this on and make it go this way, it has twisted, and now it's facing the right way. Question is, will it be able to handle this corner pretty well? I want to say yes. I want to say that it will. And the answer is no. No, it will not. So this leaves a conundrum. The problem is, because this red piece is on a corner, and that red piece is the only way so far that can stop this drone, the drone sees that red piece when it's turning and then stops itself. And that's a big no-no. The way to fix this actually is to update this drone to a distribution node thing that I'm probably going to make. And by distribution node, I mean just a simple third sensor that will basically stop the car and start spitting out vegetables. I'm just going to hope this doesn't fall apart, and I'm going to remove that right there and put down another sensor. We'll make it sense up to 2, and the color mode will be something just completely random, like brown. Yeah, we're just going to have brown because why not? And when the brown comes on, that will trigger a timer. So we're going to put the timer, let's say, I could actually replace this stick right here with the timers. Ooh. We're going to try to make this drone as little just regular building blocks as possible. Perfect. Okay. So basically now we just connect this sensor up to this timer, And we're not going to delay it too long, but we're going to have probably a little bit over half-second delay. And that will then output to these these vacuum pumps right here. Oh. So the problem is, because I have it actually connected to both sides, this is not going to work because it'll just start randomly spewing out vegetables on the other side and throwing them off into the abyss of nothing. So what we're going to have to do is have two different timers or two different logic gates to determine which side this car is on. To solve that, I'm going to have two AND gates. One of them will connect to this side. The other will connect to the other side. Wow, what a surprise. The timer will then connect to both of them so that I can save some space. Yes, I know this is adding probably some unnecessary complexity to this area. However, I think it's probably just going to need to happen because I need to make sure that this is going to work fine. So we're going to paint this side cyan. Is that an obnoxious color? It kind of is. So let's do like a darker, a darker side like this. So let's just paint this entire section this color. Oh, yes, genius. I'm an actual genius. I'm just kidding. I'm not a Tensai. Don't worry. I am definitely not a genius. I was just saying that my ego is starting to get inflated. My ego will definitely get in check once I try this out and it doesn't work. The color mode will sense this color, and I think that's right. I think that's sensing it. I'm not sure if it's on or not. But essentially, basically, whatever sensor is sensing that color, this is the same thing as the controller issue that I'm having. I'm saying the same word over and over again. There. Okay, perfect. So once this timer gets full, it'll know that it needs to shoot out of this side only because this is seeing this side's color, and it won't shoot out of this side because of that same thing. So let's make this into an and this back into an and. The final touch for changes for the drone will be a shooting logic clicker thing. I don't know. I guess ticker thing, not clicker thing. I don't know what I was saying. We have room. I just don't know exactly how I want to do it. I might distribute it evenly around like so. So 1, 2, 4, like so. Pretty good. And then connect them all into a circle, just like I do with the spud guns. Make one of them a NAND. And we have a pretty simple shooter. Okay, I figured it out. So when this timer goes on, it's actually going to connect to this clock directly, and by that the clock will start to spin or start to tick, I believe, and then these ticks will then connect to these AND gates, which will then register and be filtered by whatever the sensor is seeing, and then that'll shoot on that side. Perfect. I think this will work. So now all we gotta do is just move these pistons over so we don't have this issue and color it brown. Okay, I think I have it set up properly, possibly, and I shall probably test it out. Hold on, let me just make this. I don't have a switch on me. Oh, do I do? I do. Okay, perfect. Let me just do this really quickly, and I think the car just got stuck on something, and that's not good at all. When I was setting this up, I came into the problem of this drone is going to basically get hit by this or get stuck by this right here because of its guiding pull of wisdom, is what I like to call it. It's pretty simple fix actually, because I was going to add sensors to each of these areas anyways. Okay, so moving the sensor right here is actually perfect, because assuming that this is on, if that is on, so this red thing is gate is on, and there's a sensor sensing a wheel, that means that it's in place, and that means this can then connect to this piston, which then shoots this out as fast as possible and should make it go boom. Oh my, oh my. That's too fast. So now these are in place, and all I gotta do now is just connect these sensors. Hopefully the car can stay in the same spot. If not, then I'll have a problem. But all I need to do is just connect these sensors up to, I think it was this right here, these black ones right here. And carrot goes to carrot. Perfect, I think. Part of me thinks I just made a redundancy error somewhere in here and it's just not going to work at all, and I'll have no idea exactly what's going on. But we're going to just hope for the best. And in order to test, we are going to turn on the carrot one. So I believe this is the on switch. So we now think there is a carrot in our Shabil, and that means that that piston should be ready to turn the other piston on when the car goes over it. If that works, then we can safely assume it'll work for the rest of it. Right now, the piston is off. That's just fine. Let's bring the car over here. And if the car doesn't turn, we're going to have to edit something in the car because that's not looking too good. The car crosses over, turns that little thingamabobber. The car is now turning. It looks fine. It looks fine. It looks fine. And it's made it over. And there it goes. Ah, haha. That's what I forgot to do. Okay, so it worked, right? Except the problem is I forgot to actually connect this sensor to the button or logic gate that actually stops the car in its tracks. So let's try that again. So at least I know preliminary that the movement works. Let's put some carrots in here to see if the distribution works as well. And I don't think that oh, it did. Yeah, so we're going to have to reset the whole thing. But I think this automation kind of works. Is running through fine. Perfect. Coming through. Stops it. Launches it. All right, it's good. The timer should time out around now. Maybe. Okay, that was a longer timer than I expected, 15 seconds. But it did work eventually. And now it's turned fine, and now it's on its way out. Okay. I have a feeling that there's something inconsistent that might happen on these type of turns because it happened over here when I was testing off camera or on camera. I'm not really sure if I'll edit that in or out, but basically it got stuck over here for some reason, and I'll need to look into exactly why that happened. But overall, it worked. It literally came in, distributed the vegetables, and now it's coming out again. And it'll start going back into this loop, hopefully, if it works. All right, it's coming down. It turns on the gate, so now the bridge should turn. It stops, pulls up, twists it, pulls down. Okay, so the problem is it's because it's too heavy. So we may need to switch over the way these chests go, like I did before here, because it's just too heavy. Oh, wait. Hold. Oh, never mind. That's just fine. Well, okay. That makes sense. It's just too heavy, and I'm not going to complain about that because we can easily just switch over to that system next episode. But I think this is a full load. Honestly, I think the automatic harvesting and distribution drone is pretty much complete. All I need to do is add some more aesthetics, maybe figure out if I can make this control room look a little bit better with the outputs and stuff, and then we'll be good. Next episode, we are going to make sure these are all finished and make sure everything's working, and then we will start working on the automated planting for this. Let me know if you have any good suggestions, and I'll get back to you and hopefully get that in. Right now, I made a temporary fix that over twists the bridge and then twists it back a little bit and then drops it off, and now it works. And that should work almost 100% of the time. So I'm going to leave it like that for now. Let me know what you want. But until then, I hope you guys have a great morning, afternoon, night, or evening, and I will see you next time.